Okay, so today's lesson is called concavity in the second derivative. I thought you said. Okay. Okay, so from Friday and from before, what does f prime of x tell us again? Oh, I appreciate though how much you helped Jack, but I'm still gonna pass you on you on this one. Okay. Yeah, go ahead. Tells us our slope, right? Tells us, I'm gonna say if our slope is increasing or decreasing. If our slope is positive or negative. We're going to say f double prime of x f double prime of x tells us if the slope is increasing or decreasing. And I'm going to draw 4 pictures for you right here to make sure that you understand what I say when I say that there's a positive slope that's increasing or a negative slope that's increasing, what the difference in shape will actually look like here for that. Okay, so I'm going to draw 4 diagrams. Diagram number 1 is going to be f prime of x is greater than 0 and f double prime of x is greater than 0. That is a positive slope which is increasing. Okay, so the f prime of x is greater than 0 means that it's a positive slope. F double prime of x tells us that it's increasing. What is a graph that's positive and increasing going to look like? Yeah, it's going to look like the right-hand side of a parabola, is what you guys were saying, okay?
Yeah.
That'd be like a...
Or an exponential function would be the other
Yeah,
one. Exponential function, okay? Because if you take a look, it's a positive slope, but it's getting more positive, more positive, more positive, more positive, more positive. Okay, so everyone see? Get the idea of that? Graph number 2 is going to be f prime of x is greater than 0, and f double prime of x is less than 0. Can somebody tell me what that means in English, and then we'll do the graph? What does that mean in English? Chris, be brave, go ahead.
That it's a positive slope, but it's decreasing.
Good. What does it look like, similar than Chris and Derek, a positive slope that's decreasing? So I see you, go ahead. Yeah, the only thing is it can't go over the hump though, right? It only goes up to the hump. So this would be one that looks sort of like this. Okay? It can't actually continue down this way, right? Because that would be a negative slope. So this is still it's still positive, 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 positive. Okay? And this would be like the left-hand side of a parabola. You can look at it that way. Okay, right? The left-hand side of a negative parabola. Right? Okay, it's going up, 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 up. So everyone see that's a positive slope, but it's getting less positive as it gets all the way over to 0. We get the distinction between those two, I hope. Brad, how you feeling? Brad, you sort of okay? I can't help it. You're sitting in the bad spot for me that you're the person that I pick on. Sure, I'm sorry, Brad. That's just I'm just saying that's, I don't know why. It just, whoever sits sort of in that, Austin could get you. But that's in that sort of range is what we're picking on. Okay, now graph number 3. This is the third case. It's going to be f prime of x is less than 0. And f double prime of x is greater than 0. All right, let's pick on James. James, I'd like you to be brave. What does f prime of x is less than 0 mean? Negative slope, very good. and f double prime of x means it's going to be increasing. Okay, now this is what gets people mixed up this one always. Okay. Now, so if it's a negative slope and it's increasing, that means it's getting less negative. Okay. So what's a graph that's going to be a negative slope but is getting less negative going to look like? The same two guys always raise their hand. Yes, Emma, go ahead. Yeah, very good. Okay. Right, so if you take a look, it's very, very positive, right? Very positive, very positive. It's getting less positive all the way up to 0. Okay? Because it's when you say the graph is increasing, the idea is the slope is getting less negative.
Oh, okay, yeah, okay.
And this is the confusing one always. That one gets people. Okay? And I'll finish it off in number 4. It's going to be f prime of x is less than 0. F double prime of x is less than 0.
It's going, I
Negative
guess.
slope. Decreasing. It's going to look something like this.
Which arrow is for 3?
Whoa. I guess both of them, I guess, technically.
Okay.
You probably would look like this, though. Probably the arrow would probably make more sense to be on the. We'll probably look at that. Okay, those are the 4 cases, and that's what we're going to have to graph today. Now, I'm going to make you guys use a double interval chart. Okay, so the intervals are going to be big. We're going to use f of x and f prime of x. Sorry, f prime of x and f double prime of x to get the shape of this graph. This will tell us exactly where the points of inflection are. It is actually a point of inflection when f double prime of x is equal to 0, because that's when the graph turns. It's still positive, but it actually makes it kick like what Noah would say. Okay, that's the point of inflection. Okay. Yeah, go ahead.
Do we have a positive slope?
What's that, sorry?
Number 3. That was like a positive slope.
Well, no, it's just saying because you're going left to right. You know what I mean?
Oh, I see why it's there.
Well, it doesn't matter though, right? You're always in a graph. Just always in a graph. You look left to right. You know what I mean? Like, so this is, even though the arrow's up that way, just think of a parabola, right?
Oh, yeah.
You have 2 arrows, right? But it's going to be negative, slope, negative, negative, and then positive, right? Okay, are we sort of good? Now, again, as I said, 3 and 4 are always tricky for people. That always gets people year after year after year. Yes.
Does it matter where like the axis is or like?
No, that's an advanced function term roots. For advanced function. For calculus, we worry about the roots of f prime of x and f double prime of x. That's what that gives us there. Okay. All right, here we go. Example 1. And I have to bring batteries in. Oh, why do I forget it?
It makes me kind of happy that the class is old, so.
It doesn't. Yeah, well, yeah.
Oh, true. Sad.
Okay, you're going to see something like this on your test on next Tuesday. Okay, this is going to be the easy question, okay, because the hard question will involve a rational. Okay, but a polynomial function after today, we should have done enough that you're confident to say, yes, I can graph any polynomial function. That should be your goal after today. And I know what you're thinking. You're saying, my name's Derek, I could have graphed one of these last semester, but you couldn't, okay, in the same manner as it won't be as exact in calculus, okay, as what you do now, all right? Okay, so can somebody give me Emma, be brave and tell me the first thing, if you were to get this and you don't know what to do, what's the first 2 things I can do instantly for this? First derivative of what you're going to do. So, Emma, can you please be brave and do the first derivative? Okay, good. And I'm going to leave a little space in my note because I'm going to want to find the roots for that in a sec. right, Haley, can you find F double prime of X for me, please? Oh, that's okay. Okay, now a few people on their last test, the question involving Mr. Sadler maximizing profit, they didn't take the derivative, okay? If you don't know where to go, and you get stuck on a question, and you don't know what to do, take a derivative, you'll get a mark, okay? Right, so if on this graph you don't know what to do, start by taking derivatives, that'll get you some marks, okay? And Chris, it wasn't you, okay, that did that, okay, but it's, but just, there's about 3 or 4 people that didn't do that. So, I like what Haley said she was doing. She said she was factoring this. So like we said before, we're going to do 0 equals 3x squared minus 6x minus 9. Austin, cool. As soon as you see a 3, a 6, and a 9, what are you instantly going to do?
All 3 out of that.
Instantly. All right, I'm actually going to probably move this to the next one. I just love technology. I feel like I'm Iron Man. You ever see Iron Man where he's got like the TV and he throws stuff to the garbage, and I feel like Iron Man. All right, so I'm almost done here. Noah, how do I factor that quadratic, please?
Factor it out.
Somebody help him. He's freezing right now. It's okay. Chris, go ahead.
Okay, so you do M&A, and
Yeah.
I got an answer of x minus 3 and x plus 1. Well, if you take out the 3.
Yeah, that's okay. We'll leave it like that. All right, Brad. What is x equal to then?
Now 3 and negative 1.
Good. All right. We're looking good, but not yet great. Callan, what does that actually mean when x equals 3 and x equals 1? What are those points? Do you recall from Friday? Yeah, good. So what's it in English, though, for those that don't know what a critical point is? Have your test. I'll help. Nathan, you want to help you? That's okay. Yeah, it is a critical point, you're right, but this is when your slope is equal to 0. And just for fun, what I'm going to do is I'm going to find f of 3 and f of negative 1. I'm going to do that so I want to actually want to graph those points on there. So what's f of 3? Well, I'll see if I can do it in my head.
Oh, you're not putting it into the derivative, you're putting it in the original?
In the original. Well, because here's the thing, Chris. If you do f prime of 3, you're going to get an answer of 0. That's what we just learned here.
Oh, right, yeah, sorry.
Okay. So f of 3 should be 27 minus 27 minus 27 plus 10, which is negative 17, I think.
Yep.
And negative 1 minus 3 is negative 6. Plus 9 is 3, 13. Somebody confirm these for me?
I got 15 for negative 1.
You have 15?
It's negative 1 minus 3 plus 9 plus 10.
I thought it's 12.
I got 15 too.
15? I trust you guys. I did that in my head, so I trust you guys.
Oh, never mind.
Okay, stay with me. Fellow at the back that just came in, is serving my class. Stay with me, please. Okay. All right, so f double prime of x. We're getting close. We still got to finish up here, though. All right, Brendan, since you're sitting all by yourself today, how do we? You're going to tell me how to solve this, please. You can't take a 6 out. Yours. Okay. Yes. I'm just going to do it. I'm just going to do this. But yours actually, you could have taken a 6 out. Now this again is going to be we call this a point of inflection, is what we call this. Okay, I'm going to open the door, feel the heat turning on. And while I open the door, please don't find out for 120. Good.
You can do it, Teresa. I believe in you.
Okay. No, so all we're gonna do here for f of 1 is just something here. So 1 minus 3 is minus 2. Minus 9 is minus 11, so it's negative 1.
So anytime you get an
Hey, yes. Inflection just means when the graph sort of doesn't hit. Remember how last week, remember how x squared or x cubed looks like this? This is the point of inflection in here. It's this is still a negative slope the whole way through, but when it goes from like going up to going really up, you know what I mean?
So it could be like the vertex.
Sort of think of it like a vertex, it could be, okay? It's like a change from a positive second derivative to a negative second derivative. All right. Okay, now for the fun part that every student loves. And I swear I'm not being sarcastic when I say this, which we're going to do a giant interval chart right now, okay? Now, Luke, I know you love interval charts, okay? It's more than anybody else in this class, probably, okay? So we're going to do a giant interval chart. Now, the nice thing is, once you know how to do this, this is really easy. It's just filling in the numbers. That's all it is, okay? So, what you use for your intervals? Can somebody be brave, Austin, and tell me what I use for my intervals?
X minus 3.
Good. You're going to use all your zeros all the way through. Okay, so you're going to use your, what's your smallest one? Negative 1 to negative infinity, then negative 1 to positive 1, then positive 1 to 3, and then positive 3 to positive infinity, right? So you basically use everything that we did in here, all right?
Question. Well, why did we put in like the roots into the original equation?
Because just so we can graph them.
Oh.
When we actually graph it, we can get those exact points. The other points I had here, just so I have it on my graph, were 3, negative 17, and negative 1, 15. Okay, so here we're going to say f of x.
That makes sense.
Really? That's awesome.
F prime of x, I'm going to use x minus 3 and x plus 1. Then you're going to have 6. Okay, so there's a lot on my interval chart here. Chris, please, since you always raise your hand, which I appreciate, and it's your turn. Where did I get all of those things on my interval chart?
Sorry?
Where did I know to put all those things on the left-hand side? Where those all come from?
Okay, so the first two are the roots of they're like the roots of the first derivative.
Yes.
And then the overall, and then the root of the second derivative,
Yes.
right?
Yes.
Okay.
That's exactly where they come from. Okay. So I'm going to draw on here. Lots of arrows here. And shape is going to be just what the graph looks like. So my first interval we said from x is less than negative 1, is that right? Negative 1 is less than x is less than 1. 1 is less than x is less than 3. And x is greater than 3. Now let's say that your name is Luke, okay? Or anybody else. And Luke says, I hate interval charts, I'm not doing one. Who do you, Mr. Sadler? Okay, I will ask for an interval chart on your test because they do ask this in university calculus. They will ask you for this to be able to do. Okay, either for inequalities or for anything, this is a skill that you will actually need here, so you will be asked for it, okay? All right. Okay, so now we just got to start picking points.
Wait, what's the, like, because there's 6x minus 6, and then under that is f prime, f double
I
prime.
guess that's basically, this is basically just because I want to get it in the same form, because on the next example, there's going to be 2 entries here. So it's whatever the entry is for f of x, I do first. Then whatever the entry is for f double prime, I put here. And then this is going to be the shape. You're going to be relating the first derivative and the second derivative. And relating both of those things. Okay, so I'm going to start off picking my test points. I'm going to do -2, 0, 2, and 5. And then it's just a matter of subbing in all the different values. So negative 2 minus 3 is a negative. Negative 2 plus 1 is a negative. My first derivative is positive. Negative 12 minus 6 is a negative. Now, here's the tricky part. I'm going to give you guys a second to copy that down. Okay, and then we're talking about the shape. This is what gets people mixed up. I have a first derivative that's positive and a second derivative that's negative. What does that look like then? There, go.
The second graph you had,
Yeah. So it's going to be one. It's going to be a positive slope. It's going to be getting less positive. Is that a question or stretch? Go ahead.
I thought 6x minus 6 was a double.
It is. It is. So and what happens is f prime. I should probably have written that cleaner. Basically, I'm just doing two things together, right? Like f prime of x is the top half, and f double prime of x is the second half.
So how'd you get the negative?
Oh, okay, because I'm just doing negative, I'm subbing negative 2 in here, right? So 6 times negative 2 is negative 12, right? Negative 12 minus 6 is negative. Okay, so we said this is the shape of this. It's going to be a positive slope of getting less positive. Okay, so everyone see how I did that? So it's, you didn't because you weren't here, but basically it's going to have the first derivative is your slope. The second derivative tells you if it's going up or down. So a second derivative going negative means that instead of the graph getting bigger, it's getting smaller and smaller and smaller. So it's just going to go, it's going to crest sort of like that. Okay, a positive slope would be, a positive slope and more increase would look like this, but this is going to be sort of like that.
Would it not be positive because it's two negatives?
No, right on, the first derivative is positive, right? But the second derivative is negative. Well, no, because all I'm saying is basically this just turns into this. There's only one line here, right? I'm just keeping the form because in case you have two things here, it's going to write about f prime double prime of x. Okay, go ahead. Well, I just written here. It doesn't have to be. Okay. I just kept it in here for form. I just kept it here for form because on your test and on your next graph, you're going to get a coordinate or something to graph. So which means you'd have 3 entries here and 2 entries here. So it's going to be the same. It's just for form. That's all I put it in there for. But try. You don't have to do that. Is that a question, Alan? Or
Well, so is that double prime of x just your overall for your second window?
yes. Okay.
Oh, okay.
All right, let's keep going here. 0 minus 3 is a negative. 0 plus 1 is a positive, so that's a negative. And 0 minus 6 is a negative, so that's a negative. A negative graph getting more negative is going to look like this. Okay. 2 minus 3 is a negative. 2 plus 1 is a positive, so that's still a negative. But 2 times 12 is 6 minus, sorry, 2 times 6 is 12 minus 6 is a positive. So we're going to have a negative graph that's getting more positive. Well, that's going to look like this. Okay? It's still negative, but it's getting more positive. And finally, x is greater than 3. It's going to be plus, plus, which is a plus and a plus and a plus. So it's going to look like that. Okay. Does everyone feel sort of okay on where I got all that information? Yeah, I know. We're going to graph it and then we're going to finish it, okay?
Okay.
That's good.
The bottom is.
Alistair, how you feeling? Okay. Yeah. The shape comes from, okay, guys, can I talk for 1 second, please? The shape is basically comes from here. That's where the shape comes from. Okay, like, so for the first one, we had a positive first derivative and a positive second derivative. That means that's what the shape is going to look like, right? So depending on which of these 4 cases comes up, that's what the shape's going to look like on your interval here. Okay, yeah. Okay, so that's good. Good thing you came after this. Good. Okay, so basically you're just thinking. You're thinking if the graph is getting steeper or getting less steep. That's what you're thinking. Okay, so this is both of these are positive slopes, but the second derivative, a positive second derivative, tells us the graph's getting more steep. Okay, so And this, then the same thing for this one, the graph's is elastic. So it's heading towards zero slope. This one's heading towards infinity slope. Right, the slope's getting more and more and more and more and more. For this one here, this, you're starting off like a negative 20 slope, it's heading towards zero. This is a negative 20 slope heading towards negative infinity. Right, so the slope's getting smaller and the slope's getting bigger. So you just basically think of, just again, it's what's going to happen if you add 5 to the slope. That's what you're thinking, right? You have a negative 20 slope. You have a negative 20 slope, if you add something to it, that's your increasing, you're adding something to it, it's going to get smaller. Okay, this is a slope, you subtract something from it, it's going to get more steep. You just think about that. I keep going for now and then we'll, so I want to get 2 graphs. Okay, as far as what the graph's going to be, I'm going to write my points here. So we had 1 and negative 1. We had 3 and negative 17. And we had negative 1 and 15. Now, one thing to know, I will be actually looking for what the coordinates of the points are, okay, on your test. Okay, so I'll want you to actually label them right where they are. If you remember up until this point, or even in advanced functions, when you did these in between points, you sort of put a flip to the graph someplace and hope that was where the curve was. Or even earlier last week, remember I just sort of said, well, it sort of looks like that. I want to actually know the exact spot now, okay? Okay, so what you're going to put your point at 1 and negative 1, which is going to be right about here. Your point at 3 and negative 17, which is going to be down here someplace. And then negative 1 and 15, which is going to be up here. Okay, so there's my dots I just drew on the graph. We're actually just going to connect the dots now and we're going to finish. Now, do we care about where the roots are? No, we're not going to, unless I ask you to find them, and I won't. All right, you have enough derivatives, enough things to find. I'm not going to make you do that. So it says on the left of negative 1, the graph's going to look like this. Okay? Between, please don't disturb in here, please. Okay? From negative 1 to positive 1, we're just going to drop like this. Makes the graph really easy to draw. Okay. Then from 1 to 3, the graph just goes like this. Then from 3 up, the graph goes like that. Okay. It's really easy to draw this graph, right? Because you don't need, it's just a smooth motion of your pencil as you do it. Okay. First question.
I get it, kind of.
To compound.
Wait.
Yes, but it will for this specific example. Okay, but what we're going to get into, if I got a graph that looked like this, where everything was above the zeros, you would have no possibility of ever getting the shape of the graph, right? And that's the thing we're getting into. I wanted to start off with a really nice example that was sort of straightforward and that you guys could see. I'm going to pick one that's a little bit trickier right now for you guys to do. All right, just so that we can feel good. But I wanted to make sure this was rock solid for most people. Emma, how you feeling? Good? What I'm gonna do is I am going to hit pause on the video, tell one joke from my joke book, and then we will move on to the next example. Kara, it's your sister. I don't want you